All right, so now we're getting into our inequalities here. We've actually kind of already done some of this when we did the domain of functions way back in January. All right, so this is going to seem really similar to you. So given a polynomial function, it has general form. We have our function, and it's either greater than 0 or greater than equal to 0, not equal to 0, less than 0, or less than or equal to 0. So that's just fancy for saying, hey, it's an inequality, okay? Now, the inequality f of x is greater than 0 when your f of x is positive. So anytime you see a greater than 0, we're talking about positive y's. If it's less than 0, f of x is negative. Okay, now graphically, this is when we talked about things being above the x-axis or below the x-axis, okay? And if you have the equals to, we are including the x-axis. All right, so name all the intervals for which f of x is greater than 0 on this graph over here. That is when f of x is above, it's positive, it's y is greater than 0. Okay, and I've got several locations where that occurs. It occurs here, from that arrow down to this point right here. It occurs right there, so between those 2 points, and then up to infinity. Okay, so I've got 3 intervals here. From negative infinity, what is that going to be, negative 3? From negative 1 to 0, and from 1 to infinity. Now, less than 0 is when we're below the x-axis, and I've got 2 locations for that. From those 2 points, so from here to there, and from that location. All right, so from, it's going to bother me, give me back my purple. So from negative 3 to negative 1, and from 0 to 1. Okay, so now we're going to do it without seeing a graph. Okay, we've done this part. We've done this where we've analyzed graphs, figure out above and below the x-axis. Now we're going to do it with algebra. All right. Solve each inequality. Here are our steps. I didn't mean to zoom in all the way yet. Get it to equal 0. Okay, so put it on the right side. Factor and solve if you can. Put your zeros on a number line. Test your zones. We've done this. I know you guys are so excited. And then write the solution with intervals. So on number 1 here, it does already have a 0 on the right side. We're going to go ahead and factor. Factors of negative 6 that add to be negative 5 are positive 6 and negative 1. Now remember, greater than 0 means I'm looking for positive outcomes. Okay, so I'm going to get my zeros. I get zeros of negative 6 and 1, so I'm going to put that on my number line. I've got negative 6 over here and 1 over here. All right, with that being just a plain old greater than, it gets an open dot. And I've got 3 zones to test. Okay, I have left side, middle side, right side. So I'm going to test the zone, I'm going to test a number in the yellow zone, so less than negative 6. So let's say I test negative 7. Okay, all I'm looking for is to see if it's positive or negative. Okay. So if I plug it in here, negative 7 plus 6 is a negative number. Then I have plugged the same negative 7 here. Negative 7 minus 1 is also negative. What happens when you multiply a negative by a negative? You get a positive. Okay, now I test somewhere in the middle, in my turquoise zone, whatever color that is. I'm going to test 0. 0 is always good. So we plug in 0. 0 plus 6 is positive. 0 minus 1 is negative. Positive times negative is negative. And then I test a number in the green zone. Okay, so greater than 1. So 2. Okay, 2 plus 6, that's positive. 2 minus 1, also positive. So positive times positive is still positive. So I have 2 really good zones here. Let's use a different color for highlighting. Let's use pink. This zone works, and this zone works. So from left to right, from negative infinity to negative 6, and from 1 to infinity. That's where my zones were positive. That's it. Okay, on number 2, you're going to factor in whatever method you learned. Okay, whether that's the X, the box, whatever, find your joy. I factor by grouping. It does already have the 0 on the right side, so I'm good there. It is also less than, so I'm looking for negative outcomes. All right, so multiply leading coefficient by the constant. Factors of negative 30 that add to be negative 1 are positive 5 and negative 6. Group GCF and GCF. That's not a 2, it's a 3. Let's try that again. And x minus 3. All of this is still less than 0. So that means my solutions, negative 5/2 or 3. So put that on your number line. Open dots because I don't have an equals to, and I'm looking for negative outcomes. So a number that's less than negative 5/2, so that's negative 2.5. So I'll probably test negative 3. All right, so 2 times negative 3 plus 5. That's negative 6 plus 5, which is still negative. And then negative 3 minus 3 is also negative. So this is going to be positive. Okay, and then test somewhere in the middle. 0. So 2 times 0 plus 5, that's positive. 0 minus 3, that's negative. So I get a negative outcome there. And then a number greater than 3, so we're testing that third zone over here. So 4. So 2 times 4 plus 5, that's positive. And then 4 minus 3 is also positive. So I really only have one zone that worked, right here in the middle, because I was looking for the negatives. So my solution is between negative 5/2 and positive 3. All right, on example 3, it is quartic, but it factors really well. It factors like a quadratic. Factors of 27 or 25 that add to be negative 26 are negative 25 and negative 1. Those factor again, x plus 5, x minus 5, x plus 1, x minus 1. Okay, now I'm looking for positive outcomes, and my dots are going to be closed. All right, I've got a bunch of solutions here. We've got negative 5, positive 5, 1, and negative 1. Okay, so negative 5, negative 1, 1. Let's extend that line a little bit. And 5. And all of these get closed dots because we have an equals to. We've got a bunch of zones to test, so give yourself some patience. I need a number less than negative 5. So negative 6. Okay, negative 6 plus 5 will be negative. Negative 6 minus 5 will also be negative. Negative 6 plus 1, oh my gosh, it's negative. And negative 6 minus 1 will also be negative. So 4 negatives in a row, we get a positive. Okay, now I am looking for positive outcomes because it's greater than 0. So this is a good solution. Now, somewhere in between negative 5 and negative 1. So negative 4, negative 3, I don't care. Okay, negative 3 plus 5, that's positive. negative 3 minus 5. That's negative. Negative 3 plus 1, still negative. And negative 3 minus 1, also negative. So you have an odd number of negatives here, which means this answer will stay negative, not an interval that we need. Now we're here between negative 1 and 1, 0. So again, we're just plugging in here, seeing if we get positives and negatives. 0 plus 5, positive. 0 minus 5, negative. 0 plus 1, positive. 0 minus 1, negative. So even number of negatives, that's a positive zone. All right, now I need in this zone between 1 and 5, so I'm going to test 3. All right, 3 plus 5, positive. 3 minus 5, negative. I just lost my train of thought. All right, we're here. 3 plus 1, that's positive. And we're here. 3 minus 1, that's still positive. You still have an odd number of negatives. You only have one negative, which means this outcome is also negative. And then well, I don't even know how many zones. That's my 5th zone. We love that. 5th and final zone, greater than 5. So 6 plus 5, positive. 6 minus 5, still positive. 6 plus 1, also positive. 6 minus 1, positive. All positive, which means we have a positive zone. All right. So I've got 3 areas where I tested positive. I got a positive solution. So over here, in the middle, off to the right. So that is negative infinity to negative 5 bracket, because it's closed. Negative 1 to 1, also brackets. And 5 infinity. All right, on number 4, I already lost my train of thought, so I'm doing great here. Oh, factor by grouping. I'm going to test that first, okay? This one does factor by grouping. I can take a 4x squared, that gives me x minus 7, and a minus 1, x minus 7. That's greater than 0, so we are still looking for positive outcomes. We get an x minus 7, 4x squared minus 1, which factors a second time. 2x plus 1, 2x minus 1. So my solutions are 7, negative 1/2, and positive 1/2. So negative 1/2, positive 1/2, and 7. No equals 2, so these all are open. And I'm going to test all 4 zones. So I need a number less than negative 1/2, so negative 1 is fine. And we're plugging in here. So negative 1 minus 7. 2 times negative 1 plus 1, so that's negative 2 plus 1 would still be negative. 2 times negative 1 minus 1 will also be negative. So 3 negatives in a row, we're still negative. Yeah, between negative 1/2 and positive 1/2, 0. 0 minus 7, negative. 2 times 0 plus 1, positive. 2 times 0 minus 1, negative. So even number of negatives, we're positive. Now we're in between 1/2 and 7, so I don't know, 1. 1 minus 7, negative. 2 times 1 plus 1, positive. 2 times 1 minus 1, also positive. You do still have an odd number of negative signs, so this is still going to stay negative. And finally, a number that's greater than 7, 8. 8 minus 7, positive. 2 times 8 plus 1, positive. 2 times 8 minus 1, also positive. So we got a positive solution there. Got two good zones in between -1/2 and +1/2, and 7 to infinity. All with parentheses, because none of these are included. All right, so you can see on this back, at least these top two, I need to get the 0 to be on the right-hand side. So on number 5, that means I'm subtracting the 4x. And we need to keep it in standard form. So that's going to go down here at the end. And now that we're less than 0, we know we're looking for negative solutions. All right, now, always look for GCF first. There's a reason I've been having you guys do the factoring. GCF first. And then I'm going to multiply leading coefficient by the constant, but if you factor by the x, whatever, find your joy. All right, so that means I'm going to do 3 times -4, and we're going to get -12. So my factors are going to be 1 and -12. Group and GCF. All right, so GCF, first group, if I can get it to work, and second group. Okay, so that means in my solutions, x equals 0, -1/3, and 4. All right, so let's draw a number line. What's going to go first on there is the -1/3, followed by the 0, followed by the 4. And because there's no equals to, all of these are going to be open. So I need a number less than, I lost my train of thought, less than -1/3. So -1 is less than -1/3. So we're going to plug it in here. Yeah. All right, so plug in 1. So we got a -1, which is negative, duh. And then 3 times -1 plus 1, so it's -3 plus 1, which is another negative. And then I have -1 minus 4, which is a third negative. So it's going to be negative there. All right, now I need a number between 0 and -1/3. So it's a little harder. Remember that -1/3 is about -0.33. So if I do -0.25, that would fall in the middle. Okay, so automatically that first one's negative because it's going to get plugged in here. Then we have 3 times -0.25 plus 1. If you want to use a calculator, can. I'm literally putting that in my calculator right now. So it's -0.75 plus 1, which is actually going to be positive. And then -0.25 minus 4, that's going to stay negative. So you have an even number of negatives. We're positive now. And then a number between 0 and 4. 1 would be a good one. So when I plug it in here, it's automatically positive because +1 is positive. 3 times 1 plus 1 is going to stay positive. And then 1 minus 4 is going to be negative. So you have an odd number of negatives, so that's going to stay negative. And then my last zone is greater than 4, so 5. So plug it in here, it's going to stay positive. And 3 times 5 plus 1 will also be positive because that's 16. And then 5 minus 4 will also be positive. So we've got a bunch of positives in a row. This is positive. So I have 3 regions where it works, because I'm looking for, actually 2 regions where it works. I'm looking for negatives. So we have less than negative 1/3, and we have between 0 and 4. So my 2 regions, negative infinity to negative 1/3, 0 to 4. All right, on example 6, we need to get the 0 on the right side. So that means I need to subtract a 10x squared. So I'm going to subtract that from here and add a 4x cubed, which I don't have any like terms for that, so it's just going to go somewhere. So x to the 4th plus 4x cubed, that's going to give me negative 9x squared minus 36x. I'm trying to kill you with this one. All right, GCF has an x. And I'm going to use a different color, and we're going to factor by grouping. Let's see, that one's going to give me an x squared minus 9. So I've got x plus 4, x squared minus 9, and the x. And that's going to factor a second time. X plus 3, x minus 3. So I've got 4 solutions there. 0, negative 4, negative 3, and positive 3. So on our number line, negative 4 would go first, followed by negative 3, then 0, then 3. Each one of these is closed though, because it has an equals to. And since we have a greater than, we're looking for positive solutions. All right, so let's test a number that's less than negative 4, so negative 5. So we have the negative. You already have a negative number there from plugging it in here. Come on. Okay, so negative from plugging in there. Then I have negative 5 plus 4, which is another negative. Negative 5 plus 3, which is another negative. Negative 5 minus 3, which is a fourth negative. So even number of negatives, that's positive. Then a number between negative 4 and negative 3, so that's going to be negative 3.5. So it's automatically negative when I plug it in there. Then I've got negative 3.5 plus 4. That's going to be positive. Then I've got negative 3.5 plus 3. That's going to go back to negative. And then I've got negative 3.5 minus 3. So that's a third negative. So that outcome's going to be negative. All right, now between negative 3 and 0, so I don't care, like negative 1. Plugging it in there is going to get me an automatic negative. Negative 1 plus 4, positive. Negative 1 plus 3, also positive. And negative 1 minus 3 is negative. So an even number of negatives, that's a positive region. All right, and then in between, so a positive one. We're going to get positive automatically from that. One plus 4, positive. 1 plus 3, positive. But then I have 1 minus 3, and there's where your negative is. And finally, a number greater than 3, so 4. Positive. Still positive. That's positive 7, so positive. And then 4 minus 3, also positive. if I'm looking for regions that are positive, I've got 3. Less than -4, between -3 and 0, and greater than +3. And these all get brackets because I have closed dots. All right, now on example 7, it already has the 0 on the correct side, so I don't have to worry about that. The problem is this thing does not factor. So if I've tried to factor by grouping, it's not going to work. All right, so we're going to go to the calculator. All right, so technically we'd use the rational root theorem, where I would take all the factors of 16, so 1, 2, 4, 8, and 16, and divide it by all the factors of 1. All right, so we have a bunch of possibilities here. I have 10 possibilities. Okay, we're going to use the calculator to make it a little easier. All right, so we're going to put this thing in our graphing calculator. Let's see. All right, go to your y equals, clear that. We have x cubed minus 9x squared plus 24x minus 16. You can see that it crosses the x-axis in 2 places. I've got a cross through and a bounce. All right, which is lucky for me because I only have 3 solutions. So we're going to find the x-intercept. See if I can find my left bound. Come on. There it is, left bound, right bound. So I have an x-intercept at 1. And then let's see the other one. Second, calc, choice 2, left bound, right bound. All right, well that didn't help me much. So let's use that 1 and do synthetic division and knock this thing down. So 1, -9, 24, and -16. So that's 1, and that's going to be -8. -8, and I don't know why I can't think. 16, and 16 and 0. All right, so my resulting quadratic is x squared minus 8x plus 16, which actually does factor, so I should have gotten a 4 on that one. Because the factors of -16 that add to be -8 are -4 and -4. All right, so including the x minus 1, I need values that are greater than 0, which is positive. And if we solve those, we're going to get x equals 1 and x equals 4. So on our number line, we have 1 and 4. And because of the equals to, these are going to be closed. So we need numbers left of 1. So that'd be 0. All right, now I'm going to rewrite this. X minus 1, x minus 4 squared. All right, so if I plug in a 1 or 0, I get 0 minus 1, which is negative. And then regardless of what I plug in here, okay, I get 0 minus 4, but I'm squaring it. Even when you square a negative number, you still get something that's positive. So negative times positive is negative. And then find one in between 1 and 4, so like a 2. Plug in again, we have 2 minus 1, which is positive. Then again, right here, when you plug in, it doesn't matter what you plug in, you're going to square it and it's going to become positive. So 2 positives gives me a positive. And then to the right of 4, so 5. So 5 minus 1 is positive. And of course, like I said before, 5 minus 4, and you're squaring it, regardless, you're going to get something that's positive. And the reason you have a repeated positive like this is because it bounced at that 4. Okay, so what it looks like, and it's kind of a weird graph, we have below the x-axis and then above, bounce above. So I am actually going to have one interval here, all right, because it's above and including. So it's from this 1 all the way to infinity because the 4 is also included. So 1 to infinity.